Hi and welcome to another Year 9 video for Maths D. So this is another chapter regarding arithmetic. So here, arithmetic is basically just mathematical calculation involving numbers. But here, today we'll focus on how to do HCF and LCM by primarily using prime factorization here. So here, just highlight the word prime factorization. Okay, you will use this, really use this to answer the question regarding prime factorization. Yeah, so here just basically two methods to use when you want to find the prime factorization of a number, right? So here you can see this is the first method, factor 3, and number 2 will be continuous division. So basically today for the examples I will just maybe use one of them or maybe both of them. Okay, let's start with this one. Okay, let's find the HCF of two numbers. Basically, HCF means the highest number that is a factor of both numbers. Okay, the reason why I will use the prime factorization is because you will deal with big numbers like this, so it's easier to you. It's easier for you to use HCF. So let's do the division method for 84. So 84 divided by 2 will be 42. 42 divided by 2 will be 21. And 21 is a factor of 3. So basically you have the first one, which is 84 equals, I will just express this in index notation. So 2 times 2 is 2 power 2 times 3 times 7. Okay. And next one will be 180. So 180, let me just do it here. So 180 will be divided by 2, 90. And then 90 divided by 2 will be 45. And 45 can be divided by 3, which is 15. 15 divided by 3 is 3. 15 divided by 3 is 5. And lastly, you have 5. So here, 180 will be 2 times 2 is 2 square. Times 3 times 3 is 3 square. Times 5. Now, for HCF, to get it, you have to use this fact, okay? You have to multiply the lowest power of each common factor of the given number. So here, this is the reason why I advise all of you to use the prime factorization, because here you can see the factors in front of you. So here, what are the common factors for 84 and 180? So here, let's have a look at 2. Yes, of course, both of them have 2. But here, the lowest power of the common factor will be this one, which is 2 power 2. You cannot use 2 power 3 because 2 power 3 is for 180, but you cannot use it for 84. So that's the reason why. Next one will be, look at 3. Both of them have 3, but the lower one will be 3 power 1, which is 3. You can use 3 power 2 because it's HCF. So basically, there you have it. You have your HCF, which is 2 power 2 times 3. Okay, here, because here you cannot use 7 and 5 because both of them do not have the same factor. 7 is 84, but you cannot find 7 on 180. And 5, you cannot find it at 84, but you can find it on 180. So they are not common. So HCF will be 4 times 3. It will become 12. Right? So that's for the HCF on 84 and 180. Right. Let's have a look at the second example. Okay, here, a rectangular field 20 meter by 15 meter is divided into smaller identical square plots of land. Find the largest possible length of a side of each square plot of land. So here, you have a 20 meter by 15 meter rectangle. You have to divide this into identical square. So basically, this is an application of you want to use HCF. So I will just use a 20. You can have 2 times 2 times 5, right? Because 2 times 2, 4, 4 times 5 is 20. And 15, you will have 3 times 5. So basically, the HCF will be 5, right? So HCF is 5. When you have this, it means that the identical square plots of land will have a length of 5. So let's prove it using a diagram. Okay, so let's see here. This is 20, this is 15. Now, when you want to have 5 for 20, so how many 5s will you get for 20? So you will divide vertically by 4, right? So 1, 2, 3, 4. So this one will be 5, 5, 5, 5. And for the 15, horizontally, 15 divided by 5 will be 3. So you will have 3 over here. So here, they are all squares with a side of 5. So there you have it. So you can have the length of each side will be, length of the square will be 5 meter. Okay, this is an application for HCF. Now let's move on to LCM. Now LCM is the lowest number that's multiple of both numbers. Okay, so basically the methods are similar. You have to, the first step will be similar. So you have to find the prime factors at 84. You can have it in example 1, just copy this down. 2 power 2 times 3 times 7, and for 180, 2 power 2 and then times 3 power 2 times 5, right? So let's check it first. Okay, it's the same. Okay, they are about the same. Okay, now for LCM, it will be a different case altogether. To get LCM, my side note, you have to multiply the highest power of each prime factors. Unlike HCF, you have to multiply the lowest power of the common factors. But for LCM, you are doing the opposite, which is the highest power of each prime factor. So let's see all the factors here. For 84, for 2, one of the factors is 2. Both of them will have 2 power 2. Okay, and let's move on to 3. For 3, which one has the higher power? You have 3 power 2. So you take 3 square. And then for 5 and 7, you have to take them also. Because you just recall when you do the method of, when you try to do long division for both numbers, you are taking all the factors over here. So your LCM will be 2 power 2 times 3 power 2 times 5 times 7. So here, when you try to multiply, it will become 1260. So there you have it. Okay, for LCM. And then next one will be example number 4. Okay, example number 4, 3 lights flash together at 7:30 a.m. The first light flashes every 36 seconds. The second light every 40 seconds. And the third light every 48 seconds. Now here, at what time will the 3 lights next flash together? So here you can see the word every for each number of seconds. So here, this is kind of clue of multiples. So 36, and then the next one is 72. The next one will be so on and so on. So for 40, with 40, 80, 120. And for 48, 48, 96, and so on. So at one moment, they will have a common multiple. So you have to use LCM over here. So let's start with 36. 36 will be 2 power 2 times 3 power 2. Okay, you can use prime factorization by your own. Okay, now for 40 second, it will be 2 power 3, which is 8 times 5. Okay, let's double check 36 first. 4 times 9 is 36. Okay, all right. So for 48, it will be 2 power 4. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So 16 will be multiplied with 3. Alright, so these are the prime factorization for each number of seconds. Now let's say for number 2, let's take the highest power of 2 here. So you will take 2 power 4. The next one will be 3. You have to take 3 square. You don't have number 4, you don't have, but you will have number 5 also for your LCM. Okay, so your LCM will be 2 power 4 times 3 power 2 times 5, which is, when you try to multiply everything, you will have 2,880 seconds, right? But when you try to convert it into minutes, you divide by 60. So here, this one, you will have 48 minutes. So they will flash together every 48 minutes. Here, since you have the time, which is 0730, you have to add 48 minutes. So I will add 48 minutes over here. So I will have here 0, 7, and then 7, 8. But here you don't have 78 minutes. So I will just subtract this one, 60, and I will put it in the hour because 1 hour is 60 minutes. I will replace 1 here. So 78 minus 60 will be 18, and 7 plus 1 will be 8. So the next time they will be flashed together, they will flash together at 8:18 a.m. All right. So that's for the example number 4. All right. Okay, so I think that we'll proceed to the next one, which is about the extra. Okay, the extra one will be quite complex here because here you have an example which is about this D. So this D will be quite hard to understand here, but here I will make it simpler for you. So let's start with A. So here express 120 and 252 each as a product of its prime factors in index notation. So let's just do the prime factorization. So 12 times 10, and then here 2 times 6. Okay, so I'll put 2 here. Okay, let me just rip this off, and then here 6 is 2 times 3. So I will take this one, and this one for the prime factors, and for the last one will be 2 times 5. So I will take the prime factors. Okay, and then for 252, I will just try to divide this by 2. So 2 times 1 to 6. I will proceed. And then here I will have, we'll just use a number 6. So 6 times 21. So 6 can be split into 2 times 3. And then 21 can be split into 3 times 7. So you will have prime factors of 2 times 2 times 3 times 3 times 7. So you can have 120 equal 2 times 2 times 2 here, you have 2 power 3 times 3 times 5. So that's for the first one. And for the second one, 252 will be, how many 2's do you see here? You have 2, so 2 square times 3 times 3 will be 3 square times 7. So this is quite simple, right? Okay, now you will use this to find the answer for part B, which is the largest integer, which is a factor of both 120 and 252, which is the HCF, and to find C, the LCM of 120 and 252. So let's proceed to B. So B is asking for your HCF. So I will just copy down the prime factors that I've found just now. 2 power 3 times 3 times 5, and 2 power 2 times 3 power 2 times 7. So here I will take the lowest power of the factors. So here I will see, I know that they have 2 in common, but the lower power will be 2 power 2, and the next one will be 3. They both have 3, but the lower power is 3 power 1, and 5 and 7 is not related at all. So what we're going to do next is, this is already your HCF. So HCF will be 2 power 2 times 3. So here 2 power 2 times 3 will be 12. Okay, so that's for the HCF. And then part C is for you to find the LCM. So same thing, just copy down this power. 2 power 3 times 3 times 5. And then for 252, you have 2 power 2 times 3 power 2 times 7. Now, in LCM, you have to use the higher power of the factors that you have, including the factors that that are being extra over here. Okay, you have the extra one. So 2 power 3 is taken, and 3 power 2 is the higher power, and you have 5 and 7. So therefore LCM will be 2 power 3 times 3 power 2 times 5 times 7. So here you will have 72 times 35, so 2520. Okay, keep this one, right? So here, let's do the last part, which is the, I think this one will be not quite difficult. It's just I have to understand this. Okay, part D, find the smallest integer n for which 120 times n is a multiple of 252. So what we're going to do is, here, you have to understand the statement. You have to compare the LCM with 120n. Okay, because here 120 is already a part of this number. Okay, so when you try to compare the LCM with 120 times n, you are actually trying to find the missing number of n, which can be multiplied by 120 to get 252, because LCM is basically all the factors of both of 120 and 252. So what we are going to do next is, you just have to remember this, okay? 120 n equal LCM. Okay, so 120 is basically just the prime factors over here times n, and then the LCM over here you can change into what you have found before, which is 2 power 3 times 3 power 2 times 5 times 7. So let's proceed. So here 120 will be 2 power 3 times 3 times 5, right? And then times n. And then the LCM will be 2 power 3 times 3 power 2 times 5 times 7. So what you're going to do next is to find n, but you have to cancel the numbers that are that can be divided. So here 2 power 3 will be cancelled because both sides have 2 power 3. So it's basically 1. And then 3 here, and then 3 power 2 here. So here basically when you try to move 3 over here, it's basically 3 squared divided by 3. So here 3 will be cancelled, but here 3 power 2 will become 3 power 1, because 9 divided by 3 is 3. And then lastly 5 will be divided by 5 here. So basically you have n equals 3 times 7. So basically this is the missing factors that you can use to multiply 120, because n here, which is equal to 21, when you multiply by 120, it is a multiple of 252, right? So basically that's it for this topic. I hope that's quite simple, except for the last one. Maybe it's quite difficult, but you will understand with time. So with that, thank you very much and see you again.